guys. Is the press showing up?
Yes, sir.
Oh. Maybe. Going and buy an OBD to the phone so you can track How about you buy a OBD2 to Bluetooth connection for your car? Like it's actually pretty cheap, so maybe like 100,000 or something. And so you can connect with your phone and you can read the. Yeah, yeah. And then you can connect with your phone and you can read all the data. Okay.
No, increase the torque.
Small.
just came in, please do the pre-test for intro to power transmission. Actually, today I'm planning to discuss gears also. So why don't you do the pre-test on gears also? Is it published? I guess it's scheduled. Hold on.
Not yet.
Yeah. Hold on. It's scheduled for next week, but week 5, 6, 7.
Okay. Belts the data.
Okay, check it out. Just refresh your Google Classroom. There should be another pre-test post-test on gears. Is next week already Idul Fitri? Not yet, right? 2 weeks from now.
Yes.
Those of you in the back, why don't you move up? It's way too empty here. Okay? Come on, 7 people move up and fill up the front row. Come on.
Yellow one, cepat yellow one.
Okay. Can we start? Are you guys done? The pre-test? Okay. Not yet. Come on, move up. Do some in the back.
Wait, sir, wait, sir.
Line E mode.
Transmissions are rare in new
Okay. So today we're going to talk about power transmissions, and I'll just give you a short introduction. We've talked about this many times, but I'll talk about it again. So you have the motor or engine, right? Into a load, let's say a pump or a blower. You got the bearing support. Now, if you recall, electric motors are good with high or low RPM. High RPM. And the torque is low. So low torque, high RPM. That's typical of electric motor. So that's why in many cases you have transmissions, right? Not a typical car transmission, but which we'll also discuss. But before that, there is often another box. And oftentimes you don't see this. You don't see the real shaft of the motor. Here there are gears sometimes planetary, sometimes compound gears, and when you have compound gears, many times the shaft output is actually a little bit offset. So this is called the gearbox. But more generically, we're talking about a power transmission. Power transmission, transmitting power, right? But it's not just transmitting, it's actually manipulating power, or torque and RPM, right? So here you have high RPM, low torque. And here you have low RPM and high torque. So this is typical, and it's not just gears. We have belts and chains, and so that's going to be our three topics: gears, belts, and chain. These are the three main power transmission when it comes to manipulating the torque and the torque and RPM. There is one more thing. It's power screws, but it's a bit different, I guess. Power screws also convert from rotary to linear, but I guess at the same time it does manipulate the torque into force and the RPM into linear motion, right? So I kind of put that separate. But when it comes to still maintaining rotational motion, then we have gears, belts, and chains. And each one has its positive and negative. Because we are going from high RPM to low RPM, oftentimes this is also called a reducer. Okay? Gear reducer, gearbox reducer, because it reduces RPM. So high RPM, low RPM, but then what you really want is not the low RPM, what you really want is the high torque. If you want high RPM and high torque, then what you really need is, how do I get from high RPM low torque into high RPM high torque? Huh? What do you need? Huh? You need a better motor, exactly. This has to change. So you cannot cheat power. You can manipulate this combination, but you cannot have both. If you want to have both, then upgrade your motor or upgrade your engine, right? Your power transmission only do the manipulation. So hopefully that lands on you. This is a quick comparison of gears, belts, and chains. This is kind of an overview before we get into gears. We have capacity, okay? Gears have high capacity, belts medium. Okay, you can add the number of belts to get higher capacity, but not real high. Chain, you can transmit pretty big torque, very big torque. Noise, very low noise, of course, designed properly. In fact, gears, one of the, well, I'll have that later. So low noise, but this is mainly because it's rubber. Everything is kind of flexible. Chain, medium noise. Life with proper maintenance. Infinite life pretty much with gears. Properly lubricated, of course, and properly designed. No contaminants and all that. But, you know, manual transmissions, they last, I don't know, what's the record kilometer you have seen on manual transmissions in your car shop? What? 600,000 kilometers. I mean, it's crazy. Again, assuming proper lubrication. Belts, always finite, never infinite. No matter what you do, materials may break down, and all this fatigue going on in the cracking. You know, there's just no way it's infinite. Chain is also finite, but you can get a very long life with it. Again, proper lubrication. Speed ratio, very precise. No way you're gonna skip two unless it's a plastic gear, and then it's a. I mean, by then the gear is damaged. I would say it's not slipping, right? So within proper operation, gears, no way you can miss the ratio. The split ratio is precise. Belts, however, is not tooth, except it's a timing belt, which is a special category, but it's smooth, right? So you can slip. There is some slippage. Chain is predictable, but there is some fluctuation, believe it or not. So when you don't feel it, because like in your bicycle, the ratio actually fluctuates, but you don't feel it because the tires is flexible enough to absorb any fluctuation. And besides, your legs are not that sensitive anyway. But there is actually a fluctuation in the speed ratio for chain. We'll talk about that. It's because of the chordal rise. It's because the chain link kind of climbs onto the sprocket. And every time it does that, the effective radius actually changes. Maintenance. Gears, I guess it depends on the application. I mean, for cars or high-speed gears, maintenance is pretty routine and important. But if you're doing like a small gearbox, less than 1 horsepower gearbox, it's nothing. It's just grease, and you pump in the grease from time to time. Belts, low maintenance. It's not like you need lubrication or anything, it just runs. The blue ones are the strength of each, by the way. Chain, because maintenance you want low, not high. Low maintenance is good. So chain, lubrication is especially important, and you have to go through with the right viscosity to the links. Okay, complexity. Gears are highly complex. The distance between the centers have to be precise. The pitch radius have to match. The module has to match. So high complexity. The mounting of these axles on bearings, pretty complex. Belts, very low. Put the pulley in, set screws, put the belt in, adjust it a bit. Very flexible. Chain is also medium complexity, just sprockets, put it on. It's relatively simple. And a little bit more comparison here. Where's my notes? Cost. Always comes out of cost. Gears, high cost. Belts. In fact, a lot of the gears are custom. So if you're an order gear, sometimes you have to do a custom order. They'll make it for you. Stock gears are out there. Not too many though. So this is why it's very high cost, low volume production. Belts are very standard. Very standard. People replace them all the time. It's really low cost. Chain, low to medium cost. Now, center to center distance. Sometimes you need to transmit something, like say this is the motor, and then this is your load, right? So this is what I mean by center to center distance. Like a pulley, belts can do longer, and chain can do even longer, because you can compound the chain application, right? So say you got a really long conveyor, okay, and this can be attached by chain. I have my red color. So you can have chain like this, and then like this, and then like this, or you can have one long chain. So with chain, you can get very long center distance. That's because it doesn't stretch. Belts stretch. Efficiency, very nice with gears. That's one of the rewards. I think it can get up to like 98% in very accurate gears. Belts is also not that low, but it's just maintenance related. If you don't replace your belt, it starts slipping, your maintenance, your efficiency goes down. Chain is also very high. Speed limits, very high speed. These things can go, tens of thousands, no problem. Belts. Why do you think belts are limited in terms of speed? Can anybody make a guess? Why does it start to slip? Okay, but it didn't slip at low speed. Why does it slip in high speed? Okay, some vibration, because it's not balanced, so some vibration, yes. Why does it expand? Centrifugal force. Okay, so when you spin really fast, things are thrown outside, right? When you spin things very fast. So stretches, and what happens? It loses contact. So it's kind of limited. Chain, you can do high, but the inertia is big, and you got some flexing also. You got some clearance in the chain, so there is some limitation. Again, for very very high speed applications, you need gears, which kind of explains, right, with your car. There are motorcycles with gears also, with the center shaft and bevel gears. I don't know, for very high speed motorcycles, do they use that, or do they still use chain? Who has a sport bike? You know what they use? I don't get into sport bikes too much. Speed ratio. You can get pretty high speed ratios. There are types of gears that can get you like 100 to 1. Belts, pretty low ratio. You cannot get really small pulley, right? If your pulley is too small, your belt turns, it turns too sharp of a radius, starts giving you problems. So the small pulley side is limited on belts. That's a problem. Chain, you can get pretty high too. Pound chain. So again, let's sum it up. The uniqueness of gears are high efficiency, high speed, very long life. It's really the best, but it's just expensive and complex. Belts, you dampen vibration, that's nice. There's also this mechanical fuse effect. If something goes wrong with belts, what happens? The belt snaps, and that's it, right? I mean, you don't damage anything on your machinery. It just stops working. So it's like a mechanical fuse if you think about it. Chain, high transmission capacity, long center distance, and cheap. That's the uniqueness of your chain. So you gotta select one depending on your applications. Now, I want to start with a discussion with the application of gears. One of them obviously in cars. So let's start with that. Let's start with manual transmission, and then we'll discuss automatics. This is a different video than I usually use, so let's give it a shot. Those of you in the automotive systems, we discuss this a lot anyway. So,
Supercars, but millions of units still exist in older cars, commercial, and racing applications. For this video, we've chosen a front-wheel drive arrangement. Our transmission model is a constant mesh-type design where gear sets are always in contact with each other. Let's start with the clutch. The clutch assembly is securely attached to the flywheel, which is bolted to the engine. It's always spinning if the car is running. The components inside this assembly allow power flow to be disconnected from the transmission input shaft. Note that the transmission input shaft does not itself connect to the engine crankshaft or flywheel. connection to engine power is accomplished with a sliding friction disc, sometimes called a clutch plate, sandwiched between the flywheel surface and a movable pressure disc.
Who here has driven manual cars? Okay. So this is what engages when you release the clutch. When you press the clutch, it actually separates. When you release the clutch, it actually connects. So it's kind of the opposite.
The clutch plate assembly is splined to the transmission input shaft, but can slide back and forth. The pressure disc gradually squeezes everything together as the driver releases the clutch pedal.
Well, clutch is not our topic, so let's skip this.
Through time to absorb. The pressure plate, what natural cover, has hooks that hold it of the diaphragm against a rhythm. Which, let's see that movement, a clutch fork and fluid reservoir. The gears.
Okay, here we go.
Each speed has a gear set, so that input speed can be different from output speed. The speed gears in this constant mesh transmission are always linked. They have diagonal or helical cut teeth for quieter operation. Notice the reverse gear set with its straight teeth. This transmission will make a familiar gear whining sound when in reverse. Input power flows through the main shaft, to the counter shaft, to the differential assembly, and out through front axles. Synchronizing gears. To make gear shifting possible, one gear in each set floats freely on its shaft, riding on a roller bearing. The other gear in each set is either connected with splines or directly machined into its respective shaft. For power output, the floating gear in each set must become securely connected to the shaft through the synchronization process. Between each gear set, there's a synchronizer hub that's splined to and rotates with the shaft. A sliding shift sleeve is also driven by this hub, which can be moved back and forth by a selector fork. Forks are connected to sliding rods that are held by the external casing. During gear selection, the fork moves the sleeve forth as a gear.
Oh,
A blocker ring sits between the sleeve and the gear. The blocker ring's job is to get everything spinning at the same speed and lined up for a synchronization attempt, or block further movement if synchronization isn't possible for whatever reason. The hub has slots, or 3 synchronizer keys that spin the blocker ring, but allow enough play so the blocker ring can adjust on the fly as the sleeve teeth approach. The shift sleeve's internal teeth are shaped to push against the keys, which in turn press the blocker ring against the gear. The ring's inside surface is conical and has ridges to engage the cone-shaped gear surface like a miniature clutch.
I don't like this explanation. Okay, the old
Manual
one.
transmission for
I think the animation is better here. Yeah, the shifting mechanism is pretty complex, so I want a better animation. Okay, but this video is also good because it explains to you the difference between what you thought gears are to be like and the constant mesh transmission. Okay, now let's watch. Okay, that's a typical gear ratio. We'll talk about that later.
a basic transmission mechanism is shown here. Here, the input and output shafts are connected through a counter shaft.
So there are two reduction here, right? So that's the power flow, small gear, big gear, small gear, big gear. Okay.
A 3-speed mechanism will look like this. It is clear that just by sliding the gears, we can achieve different transmission ratios. This transmission is more specifically called a sliding mesh transmission. They are good for controlling the speed, but they have an inherent disadvantage.
What is the disadvantage if you do this in your car?
Stop before switching.
You have to stop before you switch it. I mean, I cannot imagine how do you shift, right? So this is the problem with sliding mesh transmission. Instead, what we have,
It's quite tricky to slide from one gear. Here, the gears are always in mesh, but with a major difference. Here, the output gears are loosely connected to the shaft.
okay? So this is the constant mesh transmission. Input, output, intermediate, and output shaft. Notice that the gears are actually floating. So the gears are always connected here. There is no disconnection between the gears. The gears are always connected, but it's not connected to the output shaft. So if you do not engage the shaft with the gear here, then nothing happens, right? Because the input will rotate and along with the counter shaft, but nothing happens here. Okay? So the question then becomes, how do you join them?
If we connect only one gear to the shaft at a time, the shaft will have the speed of the connected gear. With the help of a hypothetical connector, different gear ratios are illustrated here.
Hypothetical meaning like, we'll talk about it, but just assume there is some connection. So the ratio is different depending on the number of teeth and the radius, right?
It is interesting to note that in fourth gear, the input and output shafts are directly connected.
In this case, not always.
The art of locking a loosely held gear to the shaft effectively and smoothly lies at the heart of the manual transmission. Let's see how this is done in actual practice. First of all, the main shaft gears have a synchronizer cone teeth arrangement. A hub is fixed to the shaft.
The green one is connected together. Connected meaning like welded. Okay? Think of it like welded. And the red one floats.
A sleeve that is free to slide over the hub is also used in this system. It is clear that, if the sleeve gets connected with the teeth of the synchronizer cone, the gear and shaft will turn together, or
Okay? So this is how you lock them together. There is this gray part will slide and connect them together. The question is, it's not that simple because there is a speed difference.
desired locking action will be achieved. But during the gearbox operation, the shaft and gear will be rotating at different speeds, so such a locking action is not an easy task. A synchronizer ring helps to match the speed of the gear with that of the shaft. The synchronizer ring is capable of rotating along with the hub, but is free to slide axially. Before moving the sleeve, the clutch pedal is pressed. This way, power flow to the gear is discontinued. When we move the sleeve will press the synchronizer ring against the cone.
I want you to observe the speed of the red versus the yellow. Okay? Notice the speed of the red versus the yellow.
Due to the high frictional force between the synchronizer ring and cone, the speed of the gear will become the same as the shaft.
You see the teeth
At
lining?
this time, the sleeve can be slid further and it will get locked with the gear. This
Okay.
time, the
So
sleeve
again.
can be slid further and it will get locked with the gear.
So the yellow one floats. This guy floats. This guy also floats. But as this sleeve press the synchro, this called the synchronizer, short is synchro. It's gonna clamp onto the red, and they become one frictionally. By friction they become one. And notice the teeth starts to align. And that's why you have this triangle, so it kind of aligns itself in. Okay.
The same as the shaft.
Okay, so
At this time, the sleeve can be slitted further, and it will get locked with the gear.
Okay.
Thus, the gear gets locked with the shaft in an efficient and smooth way. The same mechanism is employed to shift to other gears, such as first gear, third gear, and fourth gear. You can also see the gear lever changing mechanism.
You ever wonder why 1 and 2 is like this, 3 and 4? It's because of this fork, right? 1, 2, 3, and 4.
5. Racing.
5 is separate.
Racing.
Racing. Netral jadinya semua. Belum masukin kayak.
A fifth gear is used to turn the output shaft at a higher speed than the input shaft.
It's basically another set of gears.
Now let's see how the reverse gear works. The reverse gear uses a 3-gear arrangement, as shown.
You gotta add an extra gear to reverse, right? Because if you add 1 gear, then it reverses better.
Those, one is the idle gear. When the idle gear is pushed and connected to the other 2 gears, the output shaft will turn in the reverse direction.
Okay, so the 5th gear and R. Classically, in 5-speed transmissions like that. So 5th and R. Now, when you go to reverse, notice the gear is not the helical gear. We'll talk about this very soon. Okay, this is angled, and this is straight cut. And this is called a spur gear. And it's noisy. And that's why in reverse, if you go fast enough, or if you're having fun, you reverse fast enough, you hear the whining sound. Okay, this comes from the fact that this is a spur gear. This is a helical gear, very smooth, no noise. Okay, I have this thing here. If somebody can help me bring it to the front of the class, because I have to skip some cables there. Okay, and a couple of guys help me. You gotta this a bit. Okay, accidentally delete this extension. Okay, you wanna come up? You guys can come up here. I'm assuming this still works.
Yeah, sure.
Let's flip this because the window is on the other side. Is it locked? Yeah. Okay. Okay. So this is the shifter fork is actually shifting to the side, right? But for the sake of this rig, we just separate it into three arms. Okay. But actually, you go to the left and you push, right? So this is the first gear. Now it's not that visible. Let me show you the third gear. Okay. So you have the, let me slow it down. So you have the gray one. What color is that? The kind of yellow brownish. Okay. Okay. That's the Synpro behind there. Okay. So this is the third and the fourth. Okay. You see how the fork actually slides along and join it. Okay. This is the first and the second. And this is the fifth. Fifth is inside here and reverse. Okay, it's kind of noisy because you have to slide the spur gear. Now let's see the gear ratio. Now this is the output. When everything is neutral, I mean this is rotating, but this is actually not engaged, right? It has some grease in it, so it kind of connected, kind of, you know, it rotates it, but there is no torque. It's just grease. Now, so this is your wheel. This is your wheel. This is your engine. And so if you hold this, if the wheel is on the ground, this is on neutral, like this. Now the clutch is actually between the engine and the transmission, right? So this is fixed, so it's always connected. But when you have clutch, then when you press, you actually separate these two. Okay? So this is the first gear. Notice the ratio between the input. It's kind of okay. So you can see the input speed from here because this one rotates, right? But it actually goes down and up. So this is the output speed. And this is now, it has torque, okay? I cannot stop it. This is a 100-watt motor, and then multiply. And this is the second, okay? Slightly slower. So notice this is the first, slightly faster, yeah?
Yeah.
Faster. And then the third is even faster. Fourth. And then fifth. And then reverse goes the other way. Yeah, the ratio of reverse gear is between 1 to 2, between the first and the second gear. So that's kind of the mechanism. So the shift fork, so you see here, it's connected to different arms. Okay. So this is the fork for 1, 2. This is the 3, 4, and this is, so it's at different locations. Right? So you can play with it later.
Gini lah. Mikir-mikir.
So this is harder to shift because there is no clutch, right? There is no clutch to separate this. So you're shifting. You're asking the Synpro to do the clutch job.
5, right?
Yeah, the synchros might be doing a lot of work to try to match. For automatics, you don't have to. Yeah, we'll talk about it after this. Okay? All right. So we can put it here. So if you want to look at yeah, I think that's from a Mercedes.
Kan parking brake itu sampingnya clutch, terus rem baru
Okay, let's talk about automatic transmissions, which is more complex, by the way.
When it comes to high-performance automobiles, automatic transmissions are the popular option for easy and reliable driving. In this video, we will explore the working principles of an automatic. Automatic transmissions work based on the planetary gear set.
So, it's a bit warm, you think?
Yes. Warm.
gue ngeliat tadi ini anak makan di PCD enak banget.
Enak kok, dekat. Ini kepedesan aja. Ship this okay.
Okay, so planetary automatics use a different gear set. With the manual, we have spur gear, right? This is spur gear, and then we have helical. Now, what we have here is called a planetary gear set. So you have the sun, the planets, and the ring. Okay? So you have the sun, the planet, and the ring gear on the outside. And we start with the application. We'll see why would they use a planetary gear set.
In order to understand the process, let's take a look at the basic parts of planetary gear sets. Planetary gear sets have two inputs and one output. In automatic transmission, the output rotation is drawn from the planet carrier. The two inputs are connected to the ring and sun gears. Now, let's see what happens to the output speed when we apply different speeds to the inputs.
Now it says 2 input, 1 output, but in many applications, the input 2 is the one you fix. So if you fix input 2 or fix input 1, they have different ratios. Okay, that's the trick with planetary gear set, is that you can play with the ratio by manipulating whether you fix input 2, whether you fix input 1, or input 2, input 1, and input 2 kind of rotates in the way you want it.
Here, the ring gear is stationary and rotation is given exclusive to the sun gear. This will cause the carrier to spin, as you can see here.
So you see, you can fix 1, and the 2 becomes input and output.
The ring gear is also rotating.
So you can also have the ring gear rotates a bit, and then the ratio changes.
The ring and sun gears rotate at the same speed. In this case, the whole mechanism moves as a single unit. The ring gear speed is increased further. Turning the sun gear in the opposite direction will result in a reverse gear.
So you can also do reverse gear in this set. So this is the power of planetary gear sets as opposed to the regular gear set in manual transmission.
So the operation of automatic transmission is all about transmitting different rotational speeds into the rain and sun gears. The beauty of automatic transmission is that this speed variation can be transmitted simply by engaging few clutch packs. In the coming sessions, we will see how this is achieved in Allison. In an automatic transmission, there is no direct connection between the input and the output shafts. Rather, there is an intermediate shaft between the two. In addition, two clutch packs are used for transmitting power.
Let me explain to you a little bit about this clutch pack. This is called a wet clutch. It's a clutch that operates wet. It will work even with oil. Now, you have the gray plates and the bronze plates, right? The bronze plates have teeth on the outside. The gray plates, maybe you cannot see it, but the teeth is on the inside. So the gray plates rotates with the shaft. The brown plates rotates with the hub. So when I do press them together, they kind of float and just, each individual on their own. But when I put oil pressure and clamp them together, that's how I join the shaft and the hub. Okay? This is actually typical in motorcycles, wet clutches. But the thing with this is I can control it with hydraulics rather than a mechanical motion of links. So this is hydraulically clamped.
Pressing the clutch plates together will lock the hub to the case.
Again, we have
This
something.
is the simplest form of an automatic transmission. With this in mind, let's see how the first gear works. If the first clutch pack is applied, the input shaft will connect to the intermediate shaft. On the other hand, if the second clutch pack is applied, the ring gear will connect to the case, which will make the ring gear become stationary.
Okay, so this is the first combination. You engage C1 and C5, and you can see there is more. There are more clutch packs coming up. But this is the same arrangement, okay? The gray plates and the bronze plates, they're packed together, and it can lock this ring to the case. This big one is a case.
In order to achieve the first gear, just apply both the clutch packs together. You can note that the input shaft will turn the sun gear. Since the ring gear is stationary, the output shaft will rotate as shown with almost 1/3 of the input speed.
Okay? So ring gear is locked. Sun gear is the input. The planets are connected together with this red piece. It's called the planet carrier. And so we have that ratio.
To achieve additional gear ratios, add another planetary gear set.